Hey, good morning, guys. So today, just want to go over Chapter 7 for pre-cal. And Chapter 7 is always one of the killing chapter for the students. It's all about the trig identities, inverses, and solving trigonometric equations. So we're going to go over some of the sample question real quick. And in case that you guys are having tough time with some of the, difficulty. So let's go over the first one. So define the trig identities. So let's say we do have cosine square of x times the quantity of 1 plus cotangent square of x. So this one you want to write it in terms of sine and cosine, then you want to simplify it. Before we write it in terms of sine and cosine, we can always convert this one into one of the Pythagorean identity, which is considered cosecant square of x. And then we do have cosine square of x on the left-hand side. One thing that we notice, cosecant is considered 1 over sine square of x, and then times cosine square of x. And then put this all together, so cosine square of x over sine square of x. So eventually it's going to be written in terms of cotangent square of x. And that's the simplest one. Okay, so now let's do the one that's a little bit more difficult. So let's say that we want to simplify one of the identities, one of the rational trigonometric expression. So it's 1 plus secant square of x over 1 plus tangent square of x. So you may notice that 1 plus tangent square of x is another Pythagorean identity. So that turns out to be secant square of x. And we do know that back to algebra 2 is a rational expression, so that means this one we can split it into two parts. One thing is considered 1 secant square of x, and the other one is secant square of x over secant square of x. Well, the reason why this one can be written like this, because that secant square of x, it's considered the least common denominator. So 1 over secant, which is considered cosine square of x. And then this one just reduces, so we do have 1. And that would be the final one. Okay, so simplifying the trig identities. So now let's do another one that's a little bit more sophisticated. Okay, so anytime they deal with cosine with two different angles, or sine with two different angles. So the next one I'm about to show you here is like this. So cosine of x plus power 2 minus sine of x plus power 2. And it looks like this one we need to use the sum and difference of sine and cosine. So for the sum of cosine is written as cosine of x, cosine of the other angle, power 2, minus sine of the first angle, and then times sine of the second angle. So this one just take care of that, the sum of cosine. Now I'm going to be careful with that, the sum of sine. There's a minus right in front of here. So that means you want to put it in the group, parentheses, and then expand it. So sine of the first angle times cosine of the second angle. And then plus cosine of the first angle times sine of the second angle. So you might be wondering anything that we can simplify, reduce, evaluate. So one thing that we notice for cosine of power 2, according to the unit circle, so that one is 0. So cosine of power 2, that's 0. And then sine of power 2, that's 1. And then over here, cosine of power 2, so that turns out to be 0. And then sine of power 2, that's just 1. Okay. So now this one basically just got canceled. So we're left with negative sine of x minus, so this one got canceled also, cosine of x. So eventually it's negative sine of x minus cosine of x. The simplest form. So now the one that we just went over, those are the trig identities, simplifying the trig expressions. But now let's do the one that's considered solving trigonometric equations. Okay, so here's one of the problem. So let's say we do have 3 tangent theta to the third power, so that equals tangent of theta. So anytime they deal with the nonlinear trigonometric functions, so that means we want to bring everything all together to one side. So 3 tangent cubic theta minus tangent of theta. And then we just set that equal to 0. Another thing that you want to think about here is the factoring. So anything that I can pull out, anything that I can take out for the factor. So one thing we notice, there's a greatest common factor, so tangent of theta. So we pull that out. And then we do have tangent, 3 tangent square of theta minus 1. So that equals 0. And then the rest of this, we just want to set the factor equal to 0. So tangent of theta equals 0. And then 3 tangent square of theta minus 1 equals 0. So for tangent of theta equals 0, well, according to the given domain, this one goes from 0 to 2 pi. But you gotta be careful with this. 2 pi, it's not included. Okay, so because that's an open interval. So 2 pi, it's not included. But 0, it's included. So for tangent of theta equals 0, so that means theta must be 0, pi. And then for the other equation here, we do have tangent square of theta equals 1/3. And then once you take the square root of this, we do have tangent of theta. So that equals plus minus 1 over root 3. And then back to the unit circle. So from 0 to 2 pi, again, 2 pi is not included. So we do have 4 different possibilities. So first quadrant, second, third, and fourth. So once we find out one of the reference angles, so we can figure out the rest of those radians for the quadrants. So let's figure out the first solutions in quadrant 1. So opposite over adjacent, so we got opposite over adjacent. So that means theta, it's 30 degrees. In terms of radian, it's pi over 6. So we do have pi over 6 here. Second quadrant, we do have 5 pi over 6. And then quadrant 3, we do have 7 pi over 6. And then quadrant 4, 11 pi over 6. So for this case, we do have 1, 2, 3, 4, 5, 6 solutions. Okay, now let's try another problem. So that requires factoring. So I'm looking for the one that it's a little bit more complicated. Okay, so let's try to do this one here. So the one that we did, that was tangent. So what about something that involved with cosecants? So cosecant, and then we need to find out the inverses, the ratios, so we can figure out the angles. So let's take a look at that. Cosecant squared x minus 4 equals 0. So anytime that you deal with this, again, it's already, well, isolated with zeros, so you want to factor it. So the way to factor it, back to algebra 1, so it's the difference of 2 square pattern. So it's cosecant of x minus 2, and then times cosecant of x plus 2. So now you want to set that equal to 0. And then you want to set each factor equal to 0. So cosecant of x minus 2 equals 0. Cosecant plus 2 equals 0. So that means cosecant of x, so that equals 2. Well, the thing is that it's considered 2 over 1, because that's just a fraction, it's a ratio. And then the other one here, it's considered cosecant of x equals negative 2 over 1. And cosecant is just the reciprocals of sine. And this one, again, the given restriction, it's from 0 to 2 pi. So we do have negative, positive 2, so that means it's, again, it's all 4 quadrant. So it could be quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So for cosecant, the ratio is always considered hypotenuse over opposite. So it's 2 over 1, and then 2 over 1 for the positive. For the negative, we do have positive 2 here, negative 1, and then 2 and negative 1. And for those students might be wondering, why do I put in negative 1 for the ratio? Again, the negative sign, you can shift the negative sign up and down. So hypotenuse, it's always considered the length for the radius, so that's why it's always considered positive. But for the adjacent, opposite, it can be either positive or negative. So now, let's find out the angle here. So the reference angle, it's also the first solution. So then that would be considered 30 degrees. Because that's just a special right triangle. And it's pi over 6. So that means the rest of the angle would be the multiples of pi over 6. So we got pi over 6, 5 pi over 6 in quadrant 2, 7 pi over 6 in quadrant 3, and then quadrant 4, and that would be 11 pi over 6. So for positive and negative. So it's all 4 solutions. Okay. So now the last piece of the chapter that I would like to get in touch with, it's the inverses and also with the double trig functions. So it's not just the inverse, but also that you need to find the ratios. A lot of people having a hard time with the double trig expressions for the simplification and the evaluation. So now let's do one problem. So inverses, so anytime the restriction is not given, so we need to apply the inverse restricted range. So one thing I just want to refresh is about the restriction for the range. So it's called a restricted range. So the restricted range for inverse of cosine, it's always from 0 to pi. Okay? They're both included. And then for the inverse of sine, the restricted range is from negative pi over 2 to pi over 2. Well, the reason why that is because we talk about the graph. So in order to satisfy the graph of functions, so it must pass through the vertical line test. Okay? And then for the inverse of tangent, also, it's from negative pi over 2 to pi over 2. But for the endpoint, they are not included. So now let's deal with one of those problems with the inverse. So let's take a look at that. Tangent, inverse of sine of 4/5. Okay? So inverse of sine of 4/5. So first thing that you want to find out is the restricted range of sine. So the restricted range of inverse of sine, which is from negative pi over 2 to pi over 2. So this one we're going by counterclockwise. And we do know that's a positive ratio, so that means there's only one possibility. So that means the right triangle must be located in quadrant 1. So we got opposite over hypotenuse, and then adjacent obviously is 3, because that's a Pythagorean triple. So anytime that you take the inverse of sine or inverse of tangent or inverse of cosine, it's always giving you the angle. Well, for those who might be wondering, do I need to find out exactly what that angle is, theta? Well, it's not necessary. Okay, so this one basically just replace that by theta. So tangent of theta, is considered opposite over adjacent. So for opposite, we do have 4, adjacent, we do have 3. So the final ratio of the entire expression is 4. Okay, so now let's do one that's a little bit more complicated. So let's say that we do have cosine of 2 times inverse of tangent of, well, let's say 3 over 4. Okay? So again, first thing that you want to find out, it's about the restricted range of inverse of tangent. So for the restricted range of inverse of tangent, it's from negative pi over 2 to positive pi over 2. And it's a positive ratio, so that means the triangle must be in quadrant 1. It's opposite over adjacent, so it's 3 over 4. And hypotenuse must be 5. Again, theta, do we need to find out exactly what that is? No, we don't. So now we do end up with 2 cosine of 2 theta. So one thing that you may notice, so cosine of 2 theta, so it's considered double angles. So for the double angle, we can expand it by using the identity. So for the identity of cosine of 2 theta, it's 1 minus 2 sine squared of theta? Well, we can use any of those. It can be 1 minus 2 sine squared of theta, or cosine squared of theta minus sine squared of theta, or 2 cosine squared of theta minus 1. So I just chose one of those. And now we just want to find out the exact ratio. So it's 1 minus, so 2 times sine of theta. So back to the diagram, sine of theta, which is 3 over 5. And then you want to square the ratio. So we got 1 minus 2 times 9 over 25. So 1 minus 2 times 9 over 25, which is considered 1 minus 18 over 25. And then subtract from 1. Then that would be considered 7 over 25. And that would be the final ratio. So now, let's do the one that's a little bit abstract. So let's say that there's no number involved. It just inverses and the trig functions. So now let's do one problem like this. So let's say that we do have two different types of inverses. And then we need to find out the ratios after that. So let's say we do have sine of inverse of sine of x minus inverse of cosine of x. So again, the first thing that you want to do, you want to find out the ratio here. So anytime that you don't see any denominator, that means it's always 1. So for the restricted range of inverse of sine, it's once again, it's from negative pi over 2 to pi over 2. It's a positive ratio, so again, it's a quadrant 1. So for the ratio of sine, it's opposite over hypotenuse. And then by using the Pythagorean theorem, adjacent, must be considered square root of the quantity, 1 minus x squared. And let's say this angle here is theta. And then for the restricted range of inverse of cosine, and this one it goes all the way from 0 to pi, and it's a positive ratio, so according to the ratio here, it's adjacent over hypotenuse. That means the opposite must be square root of the quantity, 1 minus x squared. Instead of calling this one theta, so this one is say alpha or beta, any Greek letter that you like. So that means this one can be replaced by using theta and alpha. Well, because that way you can inverse of sine and cosine. And now, what do you guys notice? That's right, we can use the identity. So this one is the difference of sine. So using the identity, expand it. So sine of theta, cosine of alpha, minus cosine of theta, and then sine of alpha. So for sine of theta, according to the given triangle here, so we do have opposite over hypotenuse. So it's x over 1. And then for cosine of alpha, we do have square root of 1 minus x squared. Well, it's actually over here. So it's x over 1. So it's the exact same ratio. And then cosine of theta, back to this triangle, because that's theta. So it's root 1 minus x squared over 1. And then sine of alpha, so we do have root 1 minus x squared over 1. So basically the rest of this, it's just going back to algebra 2. Turns out to be radical, all the radical expressions. So x times x, that's x squared. And then it's the same radical, so it's 1 minus x squared, the whole quantity. And then expand it, distribute. So we got x squared minus 1 plus x squared. So eventually it's going to be 2x squared minus 1. And that would be the final ratios of the entire trigonometric expression. So any questions that you have, so make sure that you just rewind or fast forward for some of the simple problem that we talked about for this video. And thank you for watching my YouTube channel today. Have a nice day.